Question number 4 asks you to explain the pink curve in the graph below using the RT state model. Why is the curve sigmoidal in shape? Well, what we're looking at here is how fast our enzyme is going as we increase substrate concentration. Right? And so a normal Michaelis-Menten enzyme gives us a curve in blue, or teal, whatever color you want to call that, where basically as we increase the substrate concentration, the rate will increase steadily up to a certain point where it begins to level off. Now, in the case of the pink curve, the curve, instead of having a hyperbolic shape, has sort of an S shape to it. We call that a sigmoidal curve. All right, now what causes this, if we kind of follow along the curve here? Well, at the very beginning, we're adding in substrate, but the reaction velocity isn't going up very much. But then we reach a certain point where now, as we keep adding in substrate, now the velocity starts to increase dramatically before it again saturates and levels off. So this part up here, the explanation for that part's the same in both cases. It's basically we've saturated the active sites and the enzyme can't go any faster than that. The difference is really down in this region here. Now, what's happening here is what's leading to this is that initially our protein is starting out in a poor performing state. We call that the tense state. Our protein is really tense. It doesn't perform well. Right? And so because it's not performing well, even though we're adding in more substrate, that substrate isn't able to bind well to the enzyme. Right? And so if it can't bind well, then the enzyme can't act on it. But once we get our first molecule of our substrate to bind, once we have one binding event, so remember, for allostery, we need multiple subunits, so we have to have multiple binding sites. So once we have one molecule bound, what happens is that the protein undergoes a conformational change from the tense state to the relaxed state. And the relaxed state now is high functioning. It binds our substrates really, really tightly, and also then, therefore, it carries out the reaction very quickly. All right, so initially, we see poor binding in this lower region here, which is indicated by the shallow slope. But then after we get that first binding event, we now see a steeper slope where it's easier now for our substrate molecules to bind and increase the reaction velocity. And that is the explanation for number 4.